Advanced meditation functions as a rigorous protocol for auditing the brain's internal predictive architecture. Under the Active Inference Framework, human reality is an active construction. The brain does not record the world, it generates it from the top down by projecting expectations onto incoming sensory data. These generative models are organized into a strict hierarchy. The lower levels process raw sensory inputs, while the upper levels handle increasingly compressed information, such as abstract reasoning and temporal depth. This diagram maps those levels. Layer 1 manages basic sensory inputs, while Layer 4 houses the narrative self. A continuous feedback loop exists. Top-down predictions flow outward to the senses, and bottom-up prediction errors flow inward, correcting the model when expectations fail. The brain regulates this process through precision weighting. It dynamically assigns confidence to specific signals, determining whether to prioritize its prior beliefs or the new sensory evidence. The Vipassana meditation specifically targets these data pathways. By modulating the confidence assigned to incoming errors, the practice begins to de-weight the high-level narrative hubs of the hierarchy. The practice begins with absolute physical stillness, a state maintained through the intentional, active inhibition of the motor system. This immobility exploits the mechanics of proprioceptive active inference. The motor cortex does not issue movement commands, it issues predictions of proprioceptive input, anticipating the sensory feeling of a limb in motion. Standard movement occurs to fulfill these predictions. The body moves specifically to resolve the prediction error created when the brain expects a limb to be in a different position. Physical stillness acts as a hyperprior, preventing the brain from executing active inference, moving the body to fit its internal model. Unable to resolve errors through movement, it relies entirely on perceptual inference, forcing the internal model to update to fit incoming sensory data. The SART framework, self-awareness, regulation, and transcendence, describes the cognitive architecture that manages this transition, allowing the practitioner to monitor and modulate automatic reactions. By neutralizing the urge to move, the brain is forced to confront its own predictive biases. It must reconcile sensory errors by updating its expectations rather than acting them out. The Vipassana body scanning is a systematic sweeping of attention across the skin and muscles. This leads to an apparent paradox known as bhanga, the subjective experience of the body dissolving into weightless particles. Ordinarily, the brain maintains a rigid, high-level prior expectation of a solid, bounded physical self to preserve bodily integrity and motor control. Somatosensory inputs from the body normally generate prediction errors that propagate up the hierarchy to update and reinforce this solid spatial schema. During a scan, the meditator adopts a stance of equanimity, a non-reactive observation of all sensations. This equanimity reduces the precision weighting of top-down conceptual priors. The brain's confidence in its expectation of a solid physical form begins to drop. Because the expectation of solidity is de-weighted, ascending prediction errors are no longer forced to conform to a unified body map. Sensory granularity increases, while high-level abstraction collapses. The brain no longer perceives a unified physical boundary, reaching a state of minimized proprioceptive surprise. The body sensation disappears because the predictive engine stops expecting a solid boundary to exist. While scanning is wordless, the Vipassana noting utilizes rapid, neutral verbal labels like rising, falling, or pressure. Consider the default response to a sharp pain in the knee. That unpredicted somatosensory data generates a high-precision prediction error. Normally, this error propagates to the highest levels of the hierarchy, activating emotional threat schemas and amygdala reactivity. The practitioner intervenes by applying a neutral label, like heat or pressure, to the raw sensation. This label acts as a precise conceptual shortcut prior. Because the neutral prior perfectly matches the sensory data, it explains away the error at a lower level, preventing the signal from reaching the threat centers. The surprise is resolved conceptually. The system no longer needs to execute reactive, survival-driven active inference policies. By using language as a firewall, noting severs the automatic neural link between raw sensation and reactive suffering. This linguistic shortcut is driven by the right ventrolateral prefrontal cortex, or RVL-PFC. Training the noting response automates a low-effort pathway that allows the RVL-PFC to downregulate the amygdala. This creates a functional space between a stimulus and the ensuing response, restructuring how potential actions are weighed. The noting response recruits prefrontal executive hubs to functionally override evolutionary threat signals coming from the amygdala. These micro-computational shifts result in the macroscopic reorganization of three large-scale intrinsic networks, the DMN, CEN, and SN. The Central Executive Network, or CEN, provides the top-down, voluntary allocation of precision weighting during practice. The Salience Network calibrates the brain's sensory gate, determining which prediction errors deserve neural resources. In advanced states, the default mode network is profoundly suppressed and decoupled from lower-level sensory processing. This suppression reflects a major reduction in the precision weighting of autobiographical and narrative priors. These network shifts indicate that advanced meditation alters the structural routing of information, silencing the brain's default narrative engine. The ultimate computational objective of these practices is the deconstruction of the identified with self. This must be distinguished from the organismic self, the hierarchical inference structure that maintains physiological homeostasis and agents adaptive control. As the diagram shows, the brain selectively dismantles the layer 4 narrative center, while leaving organismic layers 1 to 3 intact, maintaining functional agency. This results in a selfless experience during ordinary perception, navigating the world without the habitual constraints of the narrative self. From this perspective, states of awakening, or nibbana, are modeled as the brain transitioning into a highly efficient, low-free energy regime, devoid of habituated reactivity. Through the lens of computational phenomenology, the self is revealed to be a top-down prediction, one the brain can meticulously learn to stop making.